In this experiment, we are trying to perform a goodness of fit chi-squared test, and we basically are dealing with observations and also expectations. So in this experiment, it says we have 23 offspring with the phenotype A and 23 offspring with the phenotype B. So these would be our observed phenotypes, and I've written them out here again. And with some particular theory, we don't know exactly what theory this is, but from the data, from the theory, we would expect 14 with phenotype A and 32 with phenotype B. So we now want to check whether our observed data actually are in line with the expected data. And to do so, we can calculate the chi-square value. Now, just as a quick revision, what does that mean? So the chi-square value, which is often abbreviated as chi-square, equals the sum of the observed data minus the expected data squared divided by the expected data. And that gives us a certain value, that gives us this chi-squared value, and we can compare that to the critical chi-squared value that we have in this case. So let's do this kind of calculation. So I just shift this a little bit downwards so that we have enough space. So first of all, let's calculate the observed minus expected squared divided by expected. So we do the observed minus expected squared divided by expected. And that is very simple to calculate here. So what we need to do is we just take observed. So we just simply take observed, this data point. We probably want to have a bracket around that. Minus the expected value. We square this and divide it by the expected number. So here we get a value of 5.78, and we can just simply drag that down and get the same calculation for the phenotype B. So here we have our individual observed minus expected squared divided by expected, and what we can do now is we can calculate the sum of these two numbers. So we just simply start typing sum and add these two numbers up, and we get a chi-squared value of 8.32. So this one here is our chi-squared value. Now, what does that actually mean? If we are looking at a typical chi-square distribution, we would find something like that. So this is pretty much a chi-squared distribution. As you see, it's not symmetrical. And here we have the chi-squared values, and here we have the probability density. Doesn't really matter. And what we do know is that for our 95% confidence interval here, with these two observations, we know that at a chi-squared value of 3.84, that is one of our given. 3.84, 95% of our data are in this area here. And we now need to find out whether our calculated chi-square value of 8.31 is in this range here from 0 to 3.84. And what we see is that it might be somewhere, probably somewhere here. That's our 8.31. So this means that our calculated chi-square value is way out of this 95% confidence interval that we have constructed here between 0 and 3.84. So this actually means that the observed data are way out from what we would expect from the theory, and therefore it is very clear that the data that we observe are not in line with the expected data that we would expect from our theory.